Okay, I think we were
Okay,
doing part E, right?
yeah. So turning back from where we were, we had some permanent magnets, and we had a beam which was moving, and we had to show that the beam loses energy over time. So the answer to this really depends upon the fact that when there be let's assume one of the poles is north, the other is south. So suppose, for example, it goes from north to south, and now you take the oscillations of the beam. अब क्या होगा, नॉर्थ टू साउथ में जब बीम हिल रही है तो बीम में करंट इंड्यूस होगा, and that current will induce its own magnetic field, and by Lenz's law that magnetic field will be in the opposite direction to this magnetic field, right? ठीक है? And in doing that, because it produces an opposite force, like जो current होगा in going on into the metal block, which will produce a force. So we know that if you have a current in a magnetic field, you get a force, right? And that force is in the opposite direction
Salih, you have
to,
lines to write that, you know.
no, lines ke, but I'll put down the actual answer in the marking scheme. So force opposite direction to the one into the direction of movement. अब इसका मतलब क्या है? So if you want to go, if the blocks wants to go down, so block is going down, the force is going up. ठीक है? So that's like you're always opposing the direction of the motion. तो होता क्या है? The block loses energy क्योंकि block को अब इस force को oppose करना है. The block was already doing motion, now it's opposing a force. So अगर block ऊपर जा रहे हैं तो force नीचे जा रही है. So what's happening is कि it's just doing ulta of what it should be doing, and the result is finally it loses out more energy than it should. You can, let's see what the marking scheme says. The flux linkage is the magnetic field, and the block cuts the flux. It's important how you always should mention flux. So the flux is blocked, and that cutting the magnetic field. So this is cutting field lines. That induces EMF, induces currents in the magnetic block, which cause heating, and that heating causes a loss of potential energy. So this is the answer. Fair enough? Let's move on. Let's go on to the generation of electrics of ultrasounds. So how are ultrasound produced? We have a piezoelectric transducers, which are in here. So they look like we have these crystals, and those crystals, and when you make them vibrate with an alternating EMF, they cause it, they vibrate because of the EMF. Okay? It's like you have the crystals and you make this vibrate. So when you make this vibrate, all these crystals vibrate, and because the crystals vibrate, you produce, so they resonate, and their vibrations cause sound to be produced. So crystals at ultrasound frequencies, and that's how ultrasounds are produced.
ये तो like mostly ratta type वाला.
You can ratta this from the from Sir Nishad.
Yeah, sorry.
State 3 advantages
Right,
of an optical fiber compared to a metal wire for the transmission of a signal. हमेशा याद रखो, optic fibers or
long
higher bandwidth.
Yeah.
What were you saying, Ali?
No. Serves multiple people, multiple communication channels.
It has less interference. In fact, there's like a bunch of reasons. It's in fact cheaper overall.
It's cheaper, yeah.
It's cheaper if you have multiple users.
So you can see it has greater bandwidth, does not suffer from interference. It's less weight, easier to handle, less attenuation, less power needed. Okay, you
And
can.
apparently, yeah, cheaper. Yeah,
It is cheaper regardless.
it
The
is
only
that
reason wires are cheaper is because they're already set up.
ठीक है, so less power needed. So.
No, the reason it's cheaper is because you could just send a light of multiple frequencies, and thus you're transferring multiple signals, multiple. That's why
Nahin,
it
the
becomes
material
cheaper.
actually like cheaper than wires to use
Overall,
to
yeah.
begin with. Not even overall, to begin with. It's just cheaper
No,
than
it
wires
is.
to use.
Okay,
It
let's
is.
attenuation per unit length is 0.5 decibels per kilometer. The transmitter provides an input signal of this much watts and the noise power is this much. Surely the signal power P entering the receiver is 2.1 into 10 to the power minus 5 watts. So now let's use the definition of attenuation. So you have optic fiber की length given है, signal power input की given है, और noise at the receiver given है. तो हमें पता है कि for example that attenuation overall कितनी होगी. So attenuation overall was 0.5, that was per kilometer, and now we have 57 kilometers. What was the answer to this? What's the answer to this?
57 into 0.5.
Yes, 57 into 0.5. So this is
28.5.
28.5.
yes.
So now you have that 28.5. That's the attenuation. That's 10 log of input power over output power, right? That's the
Oh yeah,
formula.
and while we're at
Yes.
it, let's answer the question of why there's a 10 over here. It's because bells, we could say, is the ratio of the logs, and decibels by virtue of using the unit decibels, we are multiplying by 10. That's why there's a 10 there.
Okay, and that should give you, the input power. This turns out to be 15 into 10 to the power minus 3. And that should give you an output of 2.1
2.1 to the 5.
minus 5. Is this the answer, Ali, Mr.
Yes, it is. I mean, show karna hai.
The minimum signal to noise ratio is 24 decibels. So SNR
Random bursts of wildness.
is 10 log. That is output over noise. Let's see. SNR given at 24, 10 log. Output पता है, noise नहीं निकालना क्या है? Oh नहीं. Okay, so हम अब
We need output
you have to
over
determine
noise.
whether so हमें पता है noise क्या है, ठीक है? So noise हमें पता है क्या है, ठीक है? So this is the worst output power, the best output power you'll receive. So
We just need to
power.
check whether it will be.
Yeah, so
We need to
this
find out
output
the
power is
value
good enough or
and-
not?
Yes.
And so the noise
We need to
is
find out SNR. SNR is not 24.
But you need to find out whether it's greater or less than at 24, basically.
Yeah. So we have an output of 10 to, so this is 10 to the power minus 7.
Minus 7.
And the output we have is 2.1 10 power minus 5. What do we
This
get?
comes out to be 14.
So we have less than the minimum the SNR, and so this is rejected. So we won't be able to distinguish, right?
Rejected.
Yes.
That's the only word Solin knows right now.
That is a random other tangent. Okay. See,
Hashtag sad life. That's a trademark.
Acha, can we go up a bit? Another way to do this would be to figure out the minimum power you need for the ratio to be 24 decibels, and then you just compare the values of the powers instead of the value of the SNR, right? So that
Yeah,
would be
that's
another.
just going about it algebraically a bit different. Yeah, that could work.
Can you explain that
Okay,
again?
move on. Another way to compare this would be to take your the minimum output noise or minimum output power, and
Acha,
compare that
the
with the
output
The
power
power.
for
actual
the
output.
signal.
So you calculate the output power and then you compare it with the given output power.
Yeah.
Yes,
Okay, same.
exactly.
Okay, let's move on. Okay. One difference in one similarity between electric field lines and gravitational field lines around an isolated positively
They are
charged
both
metal plate.
radial.
So the similarity is both a radial.
Difference direction का कर लो.
No. The both.
No,
This
the
is
field
this is
line.
wrong. Okay,
The
this is
field
wrong.
line.
My bad.
Why is direction wrong? Because
My
ये
bad.
positively charged given है और positively वैसे हाँ direction का है ना.
हाँ सही तो है.
Yeah. SN be the genius. So direction for metal
Guy
sphere,
jokes about not knowing physics.
electric field lines.
खैर मैं तो my bad बोल रहा था, but apparently I'm right. Okay, whoa.
Nice.
Yeah, I had the same reaction. You the field line, and then I just saw
Leave the
positively
sphere.
charged.
And gravitational field lines.
Let's make it away from the sphere and towards the sphere.
Yeah.
Electric field lines away from the sphere because it is as a standard it is for a positive charge, and because the metal sphere is positively charged, it would be repelled.
Towards the sphere.
And gravitational field lines are always attractive. That's why we have it towards the
So
sphere.
let's see. So 14 is less than 24. This is so the lines are radial. This is what we said. There's a greater separation between the lines. ठीक है, just because the gravitational field lines are much weaker than the electric field lines. The difference is that gravitational field lines are towards the sphere and electric field lines are directed away. So we'll be right there. Let's move on. We have a charge Q and 2 points A and B, and they're separated by distance of 10. Okay, fair enough. हमें electric field strength at point A दी हुई है, ठीक है? So let's calculate the charge. So electric field strength क्या आती है? So E equals
Q over
Q
4 pi E naught R.
4 pi R. So this is just from point X. So this is Q from point X.
Square.
Q नहीं square नहीं होगा यार, क्या हो गया? Square होगा. So this is
Okay.
R AX, and you have Q over 4 pi E naught R QA. So this is AY. Right, from here to here and from here to here. Have I done something wrong?
The mark scheme says R square, so I don't know why you're saying R square. Nahi hai.
Oh yeah. This is R squared. Sorry. Okay, and so this is, and what I'm saying is the electric field, how some part of it comes from A and some part of it comes from here, right? And you add them together. Actually, no, you subtract them.
Subtract them because the difference.
You subtract, and you have, this is 4.1 into 10 power minus 5. Q निकालना है, so you have that common 1 over 4 pi 0. R is 2.5 into 10 to the power minus 2 square minus 1 over 4 pi epsilon 0. 7.5. Note that from here to here it's 7.5 into 10 power minus 2 square.
So from
And what does that solve to? Yeah, बोलो ऐसे.
एक x to a निकाल दिया, एक y to a निकाल दिया,
हाँ, और क्योंकि x to a फोर्स यूं है और y to a फोर्स यूं है, तो हमें सब्ट्रैक्ट करना पड़ा क्योंकि फोर्सेस ऑपोजिट थी.
And the electric field strength is अच्छा, that's given.
ठीक है. Remember that electric field strength is a vector. Yes. What's the answer?
The answer is 3.2 into 10 to the minus 18. Which is basically 20 electrons worth of charge.
This is coulombs. Coulomb, no worries. Figure 2.2, sketch the variation of the electric field with distance a along the line AB. So let's see. Very near to, let's start with x. So x is 0, t to 5. So we need to sketch from here to here, right?
Mm-hmm.
Okay, so 0 to 5. Again, we need to sketch from here. Here, let me change colors.
Wait. Question दिखाना.
We are
Here. So we have to sketch the variation of the electric field strength E with the distance t. So electric field strength
A to B नहीं है? With distance D from A to B along the line AB.
no, 0 to 5 centimeters दिया हुआ है.
But that's the distance.
This
D.
is 10 centimeters.
I reckon I understand
A
that.
to B.
Oh, no. Yeah. SN is right. We have to figure from A to B. Oh. SN, sorry, I misread the question. It's not X to Y, it's A to B. So it's actually from here to here.
So
And now just note a few things. For example, note that the electric field strength here and the electric field strength here will be the same magnitude
but opposite direction.
but opposite direction. इधर बड़ा होगा और ये छोटा होगा, और इधर ये वाला साइड बड़ा होगा और ये छोटा होगा. और हमें पता है exactly इधर E at A क्या है. ठीक है, that's 4.1
10 जा नहीं पाएंगे अगर 5 ही दिया हुआ है.
क्या?
No. A to B is 5. Remember, X to Y is 10.
My bad.
And E at B because it's opposite वो है तो minus 4.1 होगा again. ठीक है. So with those observations, and note that the electric field length goes with R square. So we start at 4.1 into 10 power minus 5 somewhere here. We have to end somewhere here if I've done it right.
Yeah.
And in the middle, it has to be 0 because in the middle, everything cancels out. Iske charge and iska charge cancels out. So in the middle, the 2.5.
2.5 is 0.
Everything should cancel out. So it should look something like this.
So why is the curve like a curve? Why is it
Why
not a
does the
straight line?
curve look like this? It's because this is an inverse R square, right? So this goes with 1 over R square.
So basically inverse का जो होता है हमने वो बना दिया.
Exactly. So you make an inverse curve, right?
Yeah.
ठीक है.
That's it. Anyway.
ठीक है. So it's smooth curve with decreasing gradient from 0, 4.1 and to 2.5, and then with increasing gradient from here to here. Okay.
Good.
It's good. A small charge is placed at A. तो इधर A पे रखा है. Place the charge.
Well, I don't scroll so much.
The charge is small test charge is here.
Like a roller coaster, like.
Exactly. Up, down, up. Oh, up again.
Another loop.
The electric field causes the charge to move from the rest along the line AB. Describe the acceleration of the charge as it moves from A to B. It's like we place the charge on the roller coaster here. So charge इधर पड़ा हुआ है, ठीक है. होगा क्या? पहले चार्ज को धक्का लगेगा और वो नीचे गिरेगा, ठीक है. It's like वो बॉल नीचे आ रहा है, ठीक है. और वो यहाँ पे आएगा और फिर यहाँ आएगा. तो यहाँ पे उसकी एक्सेलरेशन आहिस्ता आहिस्ता कम होती जाएगी, ठीक है. The acceleration is initially very fast acceleration and it starts decreasing with time.
So here is Vmax.
Simply because क्या? This is acceleration.
Acceleration देखना है.
ठीक है. तो acceleration, it's like a ball is falling. If you place a ball here and the ball is falling, तो initially acceleration decrease करती जाएगी. जब इधर आएगी उसके बाद acceleration दोबारा increase करना शुरू कर देगी.
But in the opposite direction.
But
So
in
it's
the
gonna
opposite
be-
direction.
So like 2.5 पे acceleration is 0, velocity is max.
And then
2.5
it starts
acceleration.
decelerating after 2.5.
Okay.
So what you need to remember now is that it first increases and then decreases.
Oh, no. Never increases.
Sorry,
Wait.
it first.
It's at maximum, then it decreases to 0 at 2.5. Then it increases in the opposite direction
To negative
till
maximum.
it gets to B. So it's
Yeah,
negative maximum.
maximum at
A.
E, maximum at A decreases to 0,
when distance is
and this is
2.5.
decreases to 0 with an decreasing trend. I think the decrease with the decreasing gradient, and then and then increases back from to- from 2.5 to 5. Okay, and to negative the maximum. So it goes from here and then it goes to the minimum, but the magnitude becomes the same, but in opposite direction. So acceleration decreases to 0 at the midpoint and it increases in the opposite direction. So
Yeah, they
increasing negative
didn't even want the nature of the decrease or the increase. मतलब काफी simple वाला ही चाहिए था.
Okay.
Too much.
Now you need to describe with a label diagram the structure of
It's
metal
basically a square with
strain
a wiggly
gauge.
line in it.
ये जब strain gauge ऐसे लगता है.
Google पे picture खोल लो.
Square with a wiggly line. Really. Not that hard.
What's the strain gauge again?
You increase the pressure on the strain gauge, the resistance of the wire inside changes, so the resistance changes. It's like a pressure meter.
Nice.
Okay. It's a strain gauge is used to measure strain
Oh my
object
God.
invented by. So this is how it looks. Roughly what we made. Yeah, roughly what we made. Okay. And now it has a metal wire going back to the marking scheme. So it has a correct grid. It has a fine wire foil strip and a plastic insulating envelope containing the wire. Yeah. Yeah, this is a fine. Let me change colors. Fine
Yeah.
wire and also
Plastic insulating envelope.
plastic.
Plastic क्यों लगाते हैं?
ताकि वायर के साथ रेजिस्टेंस में मसला ना हो.
Smart. Who would have
Alright.
who would have known?
It's almost like we were told to write this.
Plastic insulating envelope.
That would be fun. वैसे, you know, lab में if they have no insulating and they आपको पहले electric shock लगे, then they explain why you have insulation. And that's how the teacher is teaching.
If only.
चलो इसमें in fact बताया like literally बताया कि change in resistance depends on its length. So even if you're not too sure what it is, like फिर भी थोड़ा सा idea ये दे देते हैं.
Okay, let's move on. So we are next we're given a circuit.
Yes.
Okay. Awkward looking circuit. We have a 6 volt that goes into a strain gauge. That goes into a junction A. Now A is connected to a resistor and an op amp, which is further connected to some LEDs, which are earthed
सवाल है?
here. Yes.
So the strain gauge would just act as a resistor, right?
Yes.
Yes.
Yeah, it's a humble resistor.
Okay.
So let's see what happens. So the strain gauge is initially unstrained with resistance 300. You have to use the data from 7.1 to calculate the increase in length delta L of the as that gives rise to a potential of 2 volts at A. So अगर A पे potential 2 volt हो गया है, ठीक है? A पे potential is 2. That means अगर A पे 2 है तो strain gauge के ऊपर कितना गया होगा? 4 of the 6. ठीक है? R को इसको इतना गया होगा ना, and that it divides in the ratio of the resistance. So resistance इसकी
The other one is 153.
So R plus 153. And that solves to R equals 306. If I'm right.
Yeah.
ठीक है.
And
just because it's double of this. No, मुझे कोई ख्वाब नहीं आया था कि कैसे सॉल्व होता है. It's because it's double of 153. And so now let's figure out delta R. Delta R was 306 minus 300, so that's 6.0 volts. And now we go here and look at 6. So if delta R is 6 volts,
around 8 or exactly 8.
So the delta L is 8 10 to the minus 8 into 10 to the power minus 5 meters. Okay. So this is just looking here. So we have nothing to do with the op amp. And now we go here. The strain gauge undergoes a further increase in length beyond the value in B part 1. So delta इसकी delta L बढ़ गया है. That means delta R भी बढ़ गया होगा. ठीक है. Delta R बढ़ गया है. इधर मतलब R बढ़ है. ठीक है. इसका मतलब है कि इसको strain gauge को ज़्यादा मिल रहा है. That means V plus has to be bigger than V minus. ठीक है. And since V plus is bigger than V minus, then this thing is positive here.
So
right?
Y will shine.
So Y will shine.
1 minute.
Right, I think let's check if we have this right. No, shit. Wait, V
Less
plus is
than
less
होगा?
than V.
Yeah, because
Yes.
उधर potential कम हो रहा है तो
Yeah. Sorry.
बेचारे 6
X will shine. Yeah. So the output will actually be minus 5 volts, and so X will shine. I'll let Imad explain this again.
But
Imad, come in.
okay, so what we're having basically here is that when you increase the stress more, the strain gauge will have more resistance, right? When the strain gauge gets more resistance, it will get more voltage, due to which the negative inverting input will be having more voltage than the non-inverting input. इसकी वजह से output will be negative, which means the current will flow in the reverse direction, and so it will flow through the X diode, making it shine.
Sorry. Basically, like potential at A, if you look at that, if that will go down, तो वो positive में जा रहा है तो negative से कम हो जाएगा, and then so on.
Exactly.
So Ale down.
Obvious.
Is he passed out? Oh, no, he's alive. He's alive. Okay.
Sid, what is meant by magnetic field? A magnetic field.
Area where.
Region.
Region where.
And comes
moving electric charge.
Ali comes in with his lifesaver. Where
I'd say a moving electric charge experiences a force.
Moving is necessary, by the way. If it's not moving, then you're wrong. This is.
Or you could say it's a magnet.
Moving because cutting.
Yeah. No, if it's not moving, then it won't experience a force.
The charge isn't moving.
It's either a moving charge or it's a magnet.
Yeah.
Right, you have read one of those.
The logic behind
the moving charge, you have read.
Logic behind the moving charge is कि वो cut करे या क्या logic है?
Yeah. It has to cut.
The logic behind the moving charge is it induces a magnetic field when the charge moves.
Moving charge, okay.
What
the moving charge is underlined. Yay.
You could actually write on a magnet. That's pretty simple.
You can write a magnet, yes.
That's a nice magnetic field region where a magnet experiences a force.
Not experiences a force, produces a force.
No, produce.
That's by the way, that's the lamest definition you could come up with. कुछ नहीं आता magnetic
That's
field
the
से
one
सिर्फ
CI asked excuse use wale.
No,
okay.
you just wrote region. That's so intuitive, non-intuitive. Oh my.
अच्छा, a particle of with q mass m state the direction of the magnetic field. So if you use the left hand rule, let's check out where v cos b is. This is moving to the right. So plus charge है, ठीक है?
Sorry,
So
we can't see your hand though. Sir. Left hand.
okay, so I can't draw my hand.
You can.
Guys, use your own hands. Interaction.
You should at this point be comfortable with using your own hand, or you can use the fact that.
Considering the name of the YouTube channel, let's take some whole.
Okay.
So it's coming out of the field if I'm not wrong, coming out. Can anybody confirm it's coming out of the page?
Okay, let's see.
Yes, it is.
So it's out of the page. मेरा उल्टा हाथ यही बताता है, आपका उल्टा हाथ कुछ और बताता हो तो पता नहीं. Explain why the speed of the particle is not affected by the magnetic field. Again, note that the force is perpendicular to the motion. Okay. अगर इसने इधर जाना है तो फोर्स यूं है, ठीक है? तो if the force is perpendicular to the motion, उसका जो velocity component है वो affect ही नहीं होता, perpendicular to motion. So the velocity is unaffected.
The only thing that can happen is a circular motion in such a case.
In fact,
And so
this is
the direction is only changing.
in fact this is one of the main key difference
Between
in
electric,
electric and magnetic fields. Magnetic field में there is no difference in the velocity. Electric field में there is always a difference in the velocity. Okay. So out of the plane. Let's see. Now show that the diameter d is given by here. So this.
Oh, we had to also write about the no work is done part.
Really?
Check the marking scheme. Kya? Okay,
So the
nothing else.
force on the is perpendicular, so the acceleration is always.
If you just write it,
Okay.
the force is always perpendicular, so I think that's good.
Yeah.
You have to write force is always perpendicular. There is no acceleration. Okay. So force is, by the way, force by Newton's law. If it's not obvious, F equals ma. So अगर force perpendicular है, तो acceleration कोई नहीं होगी in the direction of the velocity.
Like
So
acceleration, जो उन्होंने लिखा है, acceleration would also be perpendicular.
no acceleration means no change in velocity. Okay. Okay. Let's move back. अच्छा, आपके पास force जो centripetal force होगी, that's coming from the magnetic force. So centripetal force is the magnetic force. Centripetal force, if you remember, it's mv square over r, right? And
Yeah.
what's the magnetic force? The magnetic force is bqv.
Yes.
So let's go to red. Chuck this, and so you get r equals mv over bq. And here a lot of you might falter. They're not asking for radius, they're asking for diameter. And so if you remember that diameter is double the radius, अगर आपने गलती से O level किया है
Oh my,
तो
whoa. Saleh,
you don't want to offend people. Excuse you.
Excuse me.
Sorry.
गलती से हो रहा है. Yeah, so we'll just do part 4, and then next
Use the expression to calculate TF time. Shows the time spent in the magnetic field is independent of the speed v.
because time
is not in
is
here.
not exactly that is that.
Okay. So the velocity. So if you realize the velocity is affected by it's. Let me write. So
But what do they want us to tell for like
exactly.
2
So
months?
don't have it. So the time is. Wait, if it's
We have like 20 seconds.
time, so distance over speed. So distance क्या है 2mv over bq over v, and you lose the v, so it's 2m over bq.
अच्छा.